All right, so we're going to talk a little bit about conditional statements today. These are more commonly known as an if-then statement or an if-else-if-then statement. So a conditional statement is used in programming to make decisions or choices, and it lets you pick between certain options. So for example, in this real basic flow chart, we've just got our program starts, and then it asks some true or false question. And this is what's really important, is that computers only know two options. Something is either true or it is false. Okay. And what happens is it asks that true false question. And if it's true, it does option one. If it's false, it'll do option two. Now, these don't have to be single events. It doesn't have to be, well, if I do true, we're just going to put a check mark on the screen. If I do false, it's going to be an X. These options can lead to other things. So they can lead to deeper questions, other true false questions. They can lead to complex events happening. You can put whatever you want in them. In MakeCode, this is a snip of the if else statement. So in this case, if true, so you have some sort of a true false comparison, and we'll look at MakeCode to see how we add those in. But it has to be just a true false statement. That's all the computer understands. So if this is true, do this. If it's false, so if, for example, we take this and we decide that whatever this statement is, it's actually a false statement. That is, red is blue or 5 equals 10. So if suddenly this is no longer true, so suddenly this is false right up top, well, then we're going to jump down and we're going to ignore option one and just do option two. So that's what we're looking at is a true statement. You'll do your first choice. A false statement, you do your second choice. And that's a real basic statement for just one if else true false question. Now, if we move on and we have, for example, multiple questions we want to ask, we can look at this, an if else if then statement. Now, it's set up the same way. Our program starts and we ask a question, some true or false question. If the answer is true, we do option one. We do our first task. If the answer is false, well, maybe we're asking a second question and we ask the same things. Is this question true or false? If it's true, we're going to do option two. If it's false, we'll do option three. And again, in MakeCode, we've added the else if by clicking on the little plus icon, and we'll show you that in a second. But again, we're asking the same questions. If this statement is true, then do option one. If this turns out to be false or incorrect, well, we're going to check this one. We're going to ask, well, if this statement is true, we want to do option two. And if it's true, we'll do option two, and then we're done. Otherwise, we're going to do option three, because if these are both false, we'll jump all the way down to option three, and that'll be the end of it. Now, what's really interesting about all of these if and else statements is that once you reach a single true option, it ignores the rest of the statement. So if we decide that, well, this statement is true, so maybe 1 equals 1, it's going to do option 1, and then it's going to ignore most of the rest of this. It's going to check them, but it'll generally ignore them. And the other video that I've posted goes more into depth about how if and else if statements differ from just nested if statements. And you'll look at those in just a second. But the hardest part that I've found that most of our students have is that it's hard to create these true false statements. So most of our students will ask just open-ended questions, and a computer can't answer that. A computer has to have a true or false statement. So we have to think about how do we make open-ended questions into true or false statements, so things that only have two choices. So for example, instead of asking what's your favorite color, you could say your favorite color is red. That becomes a true or false statement. Now, if your color happens to be red, well, that's true, but what if my color is blue? Well, it means that after this, when this comes back as false, so it'd be false here, you have to have a second question. Maybe the second question is your is your favorite color red, or your favorite color is blue for the second statement? Well, if that's true, great, you can move on. Otherwise, you might have to have a third statement that says your favorite color is green, and it moves on from there. So these questions do get a little more complex. Instead of just being able to ask, what's your favorite color? You have to make simple yes or no, true, false statements. Your favorite color is red, true or false. Your favorite color is blue, true or false. So you may have to have several of these statements layered on top of each other to get all of your possible options. When we think about the microbit and the actual devices we plug into it, we have to be very specific to think about how the microbit interprets these. We can't just say, is there weight on the pressure sensor? We have to state it in such a way that the microbit actually understands. So we might ask that, is the pressure sensor value greater than 500? So that would be a test, a mathematical test. It either is or is not. It's true or false. The pressure sensor value is greater than 500, true, or it's not greater than 500, which means it's false. Now, there is some issue here where what happens if it's exactly equal to 500, which is why generally you're not going to say just greater than, it's going to be greater than or equal to some number, because that way you're not skipping out on the off chance that you have exactly a pressure of 500 on your pressure sensor. The same thing comes in when we talk about, for example, numerical values or variables. So you could just ask the question, well, is my programming variable 5, or my programming variable is 5, is that right or wrong? You'd have to do a test. The variable equals 5. Yes or no, true or false. And these statements are what you have to build. So let's look real quick at MakeCode and how we build just a real simple if then else statement. So I've already got a forever loop going, and it's got 3 options. Now, remember in MakeCode, the shape of this box tells you what you can put in it. And in this case, we're looking at logic statements. So let's do a simple question, and let's say that we're going to add a comment here that describes what we're going to do. So if a variable is 1 or is equal to 1, show a happy face. If a variable is equal to 2, show a sad face. We'll fix my horrible spelling. This is why I don't teach English. And otherwise, show a meh face. Okay. So there are 3 possible options that we have to do. So the first thing we have to do is we have to think about, where is our variable coming from? So let's add a little bit of randomness in here. And so we're going to grab an input, and we're going to grab on button A pressed. And we're going to have a second value out here. We're going to shrink this down a little bit. Whoops, wrong button. And when we press A button, we're going to create and assign a variable. So I'm going to come over here to my variables. I'm going to call this variable random number, and there's our variable. So when we press our button A, we're going to set this to a random value. Now, if I want the values to be either 1 or 2 or something else, so I can do this. So 0 to 2. So my options now are 0, 1, or 2. Okay. So there are 3 options to match my 3 here. So whenever I press A, it's going to define this variable as some value from 0 to 2. And that works fine for us. So our first thing is we have to build our equal sign. So what is our true statement? So I'm going to go back to logic, and I'm going to pull out this. You'll notice it's a hexagon, and if I drop it in there, it will replace that. So we want to compare our variable, throw that one away, our variable to that. So we'll grab our variable out, our random number. You notice it's an oval, so it fits in there. So if our random number is equal to, well, here we go, 1, then I want to show a happy face. So I'm going to add in an icon, and there's my happy face. Okay. Now I need to figure out my second piece. I'm going to right click and I'm going to duplicate. So that way I don't have to drag all those boxes out. And now my question is, well, what does it do when I'm equal to 2? Well, we'll duplicate that again. Now we need a sad face. So let's see if we can find one. There's a sad face. And otherwise, I want it to show a meh face. So we're going to duplicate again, drop in, let's find a meh face, and we'll go here for this one. So we have our three faces. Now, because I do want this to, for example, just show it and then go back, we're going to add a clear screen. And perhaps we'll add a little wait time in there. Oh, not wait, pause in this. So let's pause for, say, 1,000 milliseconds, which is 1 second. And so here we have our little program. When we press A, we're going to set this variable to a random number. If that number is equal to 1, it's going to smile. If it's equal to 2, it's going to be sad. Otherwise, it's going to show this meh face. And it's going to do it for 1 second, and then it's going to clear the screen. So we can come over here to our program, refresh it, and I'm going to press the A face. Well, so we have a sad face, which means what? It was number 2. Do it again. Oh, we got number 2 again. Oh, there's number 1, number 1, number 1. Oh, the sad face, number 2. Oh, there's a meh face. So you notice it's cycling through these because I've clicked a whole bunch of times, and that's fine. So let's go ahead and let's run the debugger, and we're going to put it in turtle mode so we can step through it. So right now, think about what it's doing. It's constantly checking, because we're in a forever loop, are any of these true? And then it pauses and clears screen. So that's why we keep seeing this meh face displayed for a second, and then it disappears. Okay. So now let's go ahead and click A. So it just showed us that it assigned the random variable. We assign the random variable and it tests. Oh, that time it was a 1. Okay. So let's actually pause it. And you can sort of see that as it goes through, it's just running through these values over and over and over. And that's fine. So when we talk about these forever loops, the keys to remember, you have to have an option for each possible choice. And each of these options represent a single true or false statement. And that's the hardest part, is turning it into a true or false statement. Is something equal to something? Is something greater than something else? So always remember that you need single true false statements to create an if, else, or else if system. Okay. And it's just logic. So always be able to ask yourselves, is this a true or a false question when we're building an if then statement?